Alright, this is Old Electronics Fan, and I have no idea what part this is. It's been quite a while since I've done anything with this. A bunch of other things kind of got in the way, and then I gave in to my desire to work on other projects, etc. So, but here we are back on this. I know I've got at least 7 parts. I don't know if part 7 would be, or this would be part of part 7, or this is going to be part 8, because I haven't edited some of what I've done the last time I did this. I will clarify that later. But here's where we are at. This radio, if you've been watching the series, you know that I've done a lot of work to this. Pretty much, well, capacitor box. These 4 capacitor boxes have all been restuffed with new capacitors. New capacitor there, a new resistor. There's a resistor hiding behind there because it was open. I put a new resistor there. There's no way you could get in behind to put that in. That one's the replacement. Hiding behind here are a couple of picofarad capacitors, and I've tested them and they seem okay. So I tell you all of that because I'm encountering distortion. I believe it was down in the lower frequencies, but only certain frequencies that it would appear. I do not know what's causing that. Now, so that's one of the problems. I've got the speaker for this. You saw me repair the cone, but I've got some rattle at times, and I want to fix that. And then this is my tone control. It's supposed to be a 2 meg tone control, and of course you can do that because you can. Let's see. So right now that's reading 4 megs. It's on the 20 meg scale, and I'm using this one because it's not auto ranging, but it and as a result it tends to respond quicker to changes, so I prefer that. But anyway, so I'm going to show you though what's wrong with this. Let's see. Yes, okay. Think for a minute what why don't I have anything? Wow. Okay. Interesting. I believe this control is made the same way as the volume control, which I had to replace because it was shot. Right now it's reading 0 ohms, and so, and we're on the 20 meg ohm scale. So let's see. Alright, so that's 1 meg, almost 1.5. There's 2. I've just barely turned this. And 4. That just went beyond the range. Let me keep going. Whoa. Alright, let's go up here. 2000 megs. Alright, let's go back down here. That's weird, because that's saying 24, 40. Interesting. Let's see what this reads if I go this way. Really? Interesting. Well, that's a bit weird, because if I go to this, I go from 4.8 to 16 megs. That must be reading something else, but that doesn't make sense. Usually, if you're across a resistance, and there's another resistor in parallel with that resistance, the resistor you're measuring usually is a lower value than it actually is. Well, let's try my auto ranging meter and see what that does. Why not? Of course, the next thing I can do, and I will, is I could unsolder one of the wires and we could see what's going on. And that will happen at some point. I'm not doing that right now, and I have a reason for that. But let's just check this out. I'd really like this ohms thing to be right there at the voltage. That's what I use most. Alright, so they're kind of agreeing. Alright, so interesting. So they're measuring about the same there. So let's go here. 1.5K and 700K, 1.5 megs, 60 megs, keeps going off, and yeah, this thing is jumping all over the place. Let's keep going. Come on. 16 megs, 17 megs. Yeah. Yeah, it's dancing all over. And this should not be reading that. It's supposed to be a 2 meg resistor. So something bad has happened to that. It's not working. Now, you might think that I'm going to go ahead and just replace that. Well, I do have something I can use, but I don't want to do that yet because I have this question. Is this the source of my distortion? And let me, if I can show you why I'm asking that question. Alright, oops. See if you can zoom in a little bit. Alright. So here's why I don't want to replace this tone control just yet. Because I'm wondering if this is the source of my distortion. It's, well, this is the signal chain. This is your detector tube, which is the last step before the audio. And in fact, the detector probably is now producing audio, although I don't see a diode of any sort on that tube. I think in some radios they actually used capacitors to filter the RF off. But in any case, from this point onward, we're dealing with audio, not RF. For those who may not be familiar with this setup, this is a two-part control, and this part controls the bias. You'll notice that this, if we follow this over here to this point, and you go over, and you see this is the cathode of this one and of this one, and then the cathode of this one comes down through this coil and is also affected. And the reason for these coils, I believe, is for stability. TRF radios were prone for squealing, doing things that were objectionable, I guess you'd call them. And so this was their attempt to deal with that. The other thing about this radio is if you don't have the metal shields around all of the tubes in the front end, you also get noise and squealing and other bad things at times. So if you're working on one of these and you run into that and you have the tubes unshielded, before you go trying to trace down the problem, shield your tubes and see if it goes away. So anyway, so this adjusts the bias on these tubes. And I think it also, this is a different setup on the detector, but you'll notice that this is also, see, where's my cathode? Yes. the cathode is tied through a capacitor to this point here. So it should be less, the bias should be less affected, but I have a feeling there is an impact when you change this. And then my tone control. Well, this is the output from the detector tube, goes into the tone control. Now I added these colors because I kept getting confused about what went where. So tone control feeds into this tube, which then feeds out here and goes down here to this connection point right here, and this feeds into this transformer. Let's see, cathode. Interesting. Okay. So the other side of this transformer goes to the cathode of this tube here, and then we follow this one, the pink wire, goes all down here and it goes here. So my best guess is that they're basically using this as a mixer to combine this output and this output, because you can, and given that this is here and these are all here, you can get output from the cathode just like you can from the plate of a tube. Now, the difference between what you get out of here and what you get out of here is that this one is in phase, this one's 180 degrees out of phase. So I'm not sure how they probably deal with it here. Okay. Yeah, so probably what's happening is this out of phase signal sent here, goes through this tube, gets shifted so that it's back in phase, and then gets sent down here. So you've got two outputs basically, the output from the cathode and the output from the plate being joined together down here. That's my conclusion. So if this is not doing its job, if the resistance is way off, it's possible that this tone control could contribute to the distortion, but I'm not sure. So I want to check this first. I've got a 2 meg pot that I want to try in place of this one, and I'll go from there. I haven't checked any of these tubes. It's a well-known fact that tube testers are useful to a degree, but they can test a tube and say it's good, but the tube isn't good, as I ran into with, I think it was my Stewart Warner. So I'm going to go on from here. This radio is in 2 halves because that's how it is. And you got the amp with this connector, and you've got the radio, the front end. And right now, they're not connected. And so what I'm going to do is I'm going to set this down, connect this to this. I know which section of this connector up here I can remove or disconnect if it comes time to try to figure out which side of the radio or which part of the radio is causing the distortion. Like I said, I'm hoping it's the tone control. That is an easy fix. If not, then I'll have to find find out what tube has the problem and go from there. The other thing, what is there? Okay. Alright, so I said there were 3 things. So this speaker has a little bit of a rattle in it. Given what I had to do to repair it, it's not entirely surprising. I have tweaked this a little bit, but I will show you how you go about fixing that and I'll show you what my approach is, and hopefully that is fixable. Let's see, what else do I want to do? Alright, put that together, and I'm going to, well, yes, I will come back once I've got everything set up, and I'm going to show you how I'm doing what I'm doing, so that you'll understand what I'm doing, and we'll go from there. Hopefully I can find the problematic frequency. Oh, and I have used at least one other speaker, maybe two different speakers other than this one. So I was trying to get the speaker out of the picture in terms of the distortion. So I'll get this set up. Alright, well, I've got myself set up. I've got my function generator right there. I'm feeding my AM transmitter, some clip leads clipped into this input. I have this little AM antenna. This went to my my system, which I never used the antenna, so I brought it down here, and actually picked up another one for $1 at a tag sale, just in case I wanted another one for some other purpose. So, you still there? Okay. Now, why did I go through all of this? Number one, I want to show you that this is extremely useful. Now, there's probably another way you can feed a signal in. Yeah, I could use my signal generator, which is hiding over there. I could do it that way. But I just decided that would work, and that's quick and easy to set up. And the other reason I did that was I didn't know how well this was going to receive using this, and so I thought this would have a little bit more power. I can crank this up a little bit more, and it seems to be working just fine. Now bear with me, because unfortunately it's going to be kind of annoying, but I don't know exactly where that frequency is going bad, and I don't even know if this is going to help me do it. I will, when I edit this, drop the volume on this so it won't be as annoying. Unfortunately, I get to be annoyed, but that's alright. I'm choosing to do this, and so I guess I will live with it. And so, let's see. So here we go. I've got my scope set up. So there it is. And I want to go up here and see if I can get... let's do... still looking awfully clean. Whoa. I don't see any distortion. Let me go back down here to this. Well, let's keep going down, I guess. That's interesting. I don't see any distortion. see any distortion. Okay, so here's the next thing I want to do then. I'm going to grab this, hopefully the batteries. Hopefully the battery's okay. We are going to, I have a CD in this that is copyright free from the YouTube music library. So, actually we want you, and that there. And what's that? Okay. Well, we'll see. Of course, that pretty much means that my oscilloscope is not going to be very helpful. Now, I did turn this tone control a little bit to clean it up, because there's a short range over which it will work, even though it's not right. Well, let's see, let's try something else. Well, that's interesting. Well, I should probably try different music. What I ran into is that if I was listening to different songs, and these were, I think in one case it was country, in another case it was oldies, and certain songs it sounded fine, other songs sounded not good, and it seemed like there were certain frequencies in the lower register that was distorting. And using my function generator, I'll need on right now, I was hoping it would reveal to me what that frequency was. Now, maybe I have to move slower, and if that's the case, I'm not going to record that. Number one, would be annoying, and number two, might take a while to find. So, but anyway, let me just, oops. Well, I don't know. that's baffling. It's not distorting, and I can't hear it. That looks fine. So, yeah. Alright, so I think the next thing I want to do then, is that what I want to do? No, actually I should probably not do that. We're going to turn this off. So, I think what I want to do next, and I haven't figured out exactly how to get you to be able to see that, because this has to be on its back. Come on. Let's go. Alright. And I've got some things I have to do. I need to make sure they seem to have used different size screw heads here. I'm not sure why. Yeah. Yes, of course. Alright, so what I have to do is I'm going to have to find, yeah, these 4 screws. Let me explain a little bit more. Alright. These 2 screws here and these 2 screws here are mounted into an angled plate which goes back to the magnet. That's what actually supports the speaker. There isn't a complete basket on this speaker. The top and the bottom of this is completely open. And so what I'm going to be doing, I'm sure this is not anything new, I'm going to be taking this screw out completely, because you run the risk if you start jockeying this around and you've got this in. This spider, for those of you who may not know, this spider is paper. It's a pressed paper. And kind of amazing it's lasted all this time. And it's really easy to wreck this. Very easy. So, so I want to take the screw out, get all these screws the same, because then what I'm going to do is I'm going to be moving this around gently. I'll have to get that set up and I'll show you what I'm doing. But my goal is to be able to move this up and down, side to side, to get that cone aligned so that it's no longer vibrating. And I am going to use my function generator. I'm going to feed the function generator into my little amplifier I have down here, and I will feed the output. I've got a test jack up here on this thing here. The test jack, I'm going to feed the speaker from that. Now I'm going to need this part because this is a electromagnet style speaker, not permanent magnet. So that means I need power coming from somewhere. Now, there are a couple of ways I could do this. Number one is I could crank my DC power supply up to its maximum voltage of 32 volts and try to use that. I have a transformer that came out of an old television set, I think it was, and I could use my isolation transformer and run that and get the voltage that I want to supply this. The other thing that, I could do what I'm going to do is I will use the radio itself to power the magnet in this. To me, that makes the most sense. I think that would work the best. Involves the least amount of fooling around, and it will, I think, allow me to do this much more simply, much more easily than it would otherwise. So that is my plan. So what I've got to do, I've got this screw I have to swap out with, say, that one, I guess, I don't know why they have different. In fact, let's see. That's not right. That is not right. That one's not right. That one is. That one is. More or less. So that's 1, 2, 3. I thought there might be 4 of them that are different sizes. I think maybe those are the 4 they used here. Yeah, so 1, 2, 3. No, not 3. That one. That's okay. That one, no. So that's 2. Huh. 3. Yeah. So there's only 3 oddball. I don't know. Not sure why they did that. I don't see the difference. That's probably, is it metric? I don't know what you are. That's too big. Yes. Really? Okay. Alright, well that's kind of weird. It doesn't, this, I don't know what this is. It's kind of an in-between size. This is quarter, and this is 7 millimeter. I think I tried a 5/16. Is that what I tried? Yeah. 5/16 doesn't work. Let's see, oh, that's metric, isn't it? Yes. It's probably something odd, like 11/30, like 11/30 seconds or something. I don't know. But so what we're going to do, though, because I want to be able to use one wrench to adjust this as I'm going about adjusting it. And I can't do that if the head of the bolts are 2 different sizes. Very annoying. I don't know. I mean, this is an old radio. Who knows? Maybe somebody lost screws when they were working on this, and they replaced the missing screws with different sizes. You just never know. So, are you going to be cooperative? All right. Now, since I don't know, I've got a lot of hours recorded on this radio, and I have no idea how much time people are going to spend watching any of this. So bear with me if I repeat some things, because I don't know who has seen what. But anyway, so now I forgot where I was going. Oh yeah, yes, okay. I remember. This looks like a felt over, I can't tell if it's paper, fabric. I think it looks like, well, yeah, it kind of looks like fabric. Some kind. One of the things I tried to do, or started to do, was I wanted to take the ring off so I could reposition the cone. And right here is where I tried to pull that apart, and the fabric, or the felt rather, is glued to the metal ring. I cannot I cannot separate this. I will simply destroy this. Thankfully, the way this is designed is that the backing plate, I don't know if I can show you that. Can I? Yeah, let's see if we can swing it around behind. Yes. So that's one of the supporting plates. There's another one there. That's bolted to the back of a metal ring, which supports the back side of the speaker, and then this ring is bolted through the speaker cone into that back ring. And then I've got these 4 bolts, as I said before, that are what's actually supporting this and positioning this. So, so let me think. Yeah. So I'm going to have to put this on its back, because in the instructions, there are actually instructions on how to align the speaker. And in the instructions, they show this on its back, and you're looking down on the speaker and you're adjusting it. And the other advantage of taking this screw out is that I will be able to see where the hole in the center of the spider is being positioned. I'm really hoping that this will be successful. Don't know if it will be. If it isn't, then I've got a problem. I really don't know if people recone this style speaker or not. I have not even looked into it. Not sure I want to, but I have a feeling it'd be very pricey. Just shipping this thing somewhere would be expensive. This thing weighs a lot. So I'm hoping, I mean, it's actually sounding sort of okay, but you can see how it's warped. And that gives me the idea that maybe, and I'm not really sure I want to do that, this is really delicate material. And I have actually, Jim's Radio Shop gave me this idea, and I've actually used it on a speaker and it worked. Gently, and I do mean gently, wipe water onto a speaker. You don't want to go crazy with the water. You want to use a brush. Do not use foam, or you very real chance you'll tear the speaker, the paper. The paper gets really soft when you get it wet, but you try to minimally wet it down, and then you let it dry. And the theory is that this is pulling it into position in one way, and then the outer edge is trying to pull it into position in another way, and the two equalize, and the cone gets centered where it belongs. And that's a possibility. If I had nothing else that I could do, I might consider that. And if I were going to do it, I would probably gently go around the outside. I would leave that part alone. So that's where a lot of my repair work was. And I was also trying to get rid of the rattles. I used rubber contact cement on each of these joints, because I wasn't sure if the rattle was coming from this stuff banging against other parts of the speaker. So, oh, yeah, there's a tear right there that's been repaired. Yeah, it came out really well. You can't really see a lot of the repair work I did, and if you saw the picture, the video where I repaired that, then you'll know why it came out the way it did. White glue is pretty sturdy stuff, and if you have enough material that's overlapping, you can get away with stuff like this. But I have a feeling when I was down in this area, it was pretty interesting trying to get all this stuff to line up and come together properly. Yeah, it was not easy. So between the warping and having to reglue it all back together, yeah, it's not a surprise that it's a little bit noisy. So, so I'm going to get this sorted out. Oh, the other thing that I just want to mention is, and then let me back up. The speaker that I used just now to try to see if this thing was distorting is one that I haven't used before. In fact, maybe I can show you that. Right, hiding in the corner. That old speaker, I don't even know. I guess it probably had, I think it was an old GE radio or something. And that was one of them. There's another one over there. These things are very old. They're 40 years old or more. This one has, I think it's around an 8-ohm speaker. The other one over that side, over to the other side, to the right of where that one is, that one is a different speaker because the speaker went bad in it, and that one's about 3 ohms. The reason I'm using those, and the reason I have them up there tied into my little system here, is because those are indeed vintage high efficiency speakers, and if you're working on something that doesn't like the modern lower efficiency speakers, it's nice to have that option of having these older speakers that will work better with these older radios. So that's why those are there, and that's why I use that with this. And as you heard, that one sounded pretty good, and I didn't have any distortion. It sounded actually normal. So I'm a little puzzled by that because, like I said, I tried at least one other speaker other than this one, maybe more than one, and I thought I had distortion, and apparently not. So, when I get this all done, actually what I'm going to do is, alright. My mind goes in far too many directions. The instructions on this tell you to feed a 50 hertz signal, 50 hertz tone into this, and adjust it to try to get rid of the rattle and the noise. I'm hoping that that's possible. So when I was looking for the distortion, I went down around 100 hertz, but I didn't go down to 50. So what I'm going to do is, if I get this aligned properly, and I'm not getting any rattling or any noise out of this, then I'll play stuff through the radio to see if I can get that distortion again. Alright, so that's the next thing, the speaker. Alright, so I've taken the screw out of there. I've loosened these up, these four up, and I don't know if I can do better. Well, I hope that's going to work. Now, so I've got my frequency generator set about where I want it, and maybe a little bit more. Okay. And Well, actually, let me tighten that down. Or not. Now I'm having to put my finger on this because it's going to rattle if I don't. Alright, let's try this. Well, that may be okay. Oh, the other thing that's unique, interesting about this one that's different than the other one, on some, on the center post on some of these, they have a little lip that sits inside. Yeah, turn that off so the magnet won't yank my screwdriver in. That the center of the spider rides against, so you actually are limited by that little lip there. I guess that shows you the range. That shows you the range of the of motion that you have for that spider. Well, this is the first time I've done this. It sounds like I've got it right. I'm not sure. So what I'm going to do now is, notice I just turned it off. 45 tubes are not, how shall I say it? It's best if you don't bang them around, especially when they're operating. So pounding on them when you're testing them in a tube tester is a no-no. Don't do that. So I want to let things cool off a little bit, and I'm going to gently reposition this. Okay, well, it didn't work out as I had planned or hoped. And I think the fault was mine. I think there was a little bit of noise there, and I wasn't recognizing it for what it was. But, so what I did was, I decided to use this song. And I used that because the good bottom end that you probably push this as hard as anything you'd want to play on it. I used that, and I went back and readjusted it just the way I did on camera. And I had to go I had to try it several different times to get it to where I'm happy. The problem is that when you loosen up these 4 screws, this whole thing comes off of here a little bit, and when you tighten it back down, things would change, and they have to tweak it a little bit, loosen it and tweak it a little bit and bring it back down. Not easy, but I think it's doing as well as could be expected. Let's try something different. are you doing that to me? Because you can. Yeah, I think that's doing just fine. So, my approach to fixing it, well, maybe a little bit unorthodox, worked, I think. The difference between using the function generator at 50 Hertz and using the music was that, at least to me, it was much more obvious when it was rattling. And if I were to, I would try my function generator again, and I would try to be more aware of the fact that the rattle, and I think thinking back to what I was hearing, I have a feeling I would recognize that again. And I'd probably be, well, actually what I might do, that's probably what I'll do. What I should do, and what I'm going to do, is I'll grab a decent speaker with, I guess it doesn't matter if it's got good bottom, actually it does matter. I'll grab another speaker similar in size to this one, one that I know is good, and I'll hook it up to my function generator and I'll listen to it. And that will give me an idea of what I should be hearing if the speaker is aligned properly. And that should then solve the problem of me not hearing clearly what is going on. Now, using the music as I did work, I believe. As you can hear, it sounds pretty good. And I'm pretty pleased with that. So what I'm going to do next, though, is I'm going to put this up on its side, try to get it stable. Maybe I'll take that tube out, put a lock under it. Anyway, I'm going to replace this tone control. So I'll be back in a moment to show you what I've done, and hopefully we'll hear how differently a working tone control behaves than what's in here. Okay, this old electronics fan, and actually forgot to turn this on before I turn the camera on, so I'll let this warm up. But we have an issue. I happen to have a 2 megohm audio taper potentiometer that not sure why that's making racket. It's been behaving itself. But anyway, this is okay. Okay, so this is the old pot. I measured this and it measured out at 4.5 megohms. That's what my meter says. I looked at this, and let's see, zoom in there. It would be hard for me to show you what it says on the, or would it? Let's try it. Anyway, right there, R4, variable resistor, 2 megs. And if we go back here, I believe, let's zoom in a little bit more, that I can actually read that better on the screen than I can looking at this. But So I believe this is indeed R4, which is right here. Here's the thing that I didn't think about. I should have, but I didn't. Except for the fact that this tone control was flaky and not behaving as it ought to. The performance of the radio was actually fairly decent, and if I moved the control just a little bit, I could get some action out of this control. As I could get a little bit more treble and less bass. And then you go a little bit further and then it would just stop working. So, what has happened to this radio since I put the new control in is basically there's pretty much no bottom end, and the reception of this radio, I'll show you that in a minute. I'm not sure why we're making noises. Hopefully I don't have a tube having issues. So why would that be? Well, let's see. Let's first of all look at the overall circuit. This is the plate, and that's just a interesting. Well, anyway, it's just a coil. C20. What do they call that? I don't know. I'd have to look that up. So anyway, so we've got this coil, and it goes straight into this leg of the tone control, and then of course the bottom leg goes to chassis or to ground, or B minus, whatever it is on this thing. And then our center piece goes out and feeds to the grid of this. So this is the output from this part of the radio. And this old radio, as some of you already know, is different than modern radios in that this control is actually a two-part control. This part of the volume control actually adjusts the bias on the cathode of some tubes, and this is also impacted by the volume control. So they change the bias on the cathode, and they change the amount of signal you get from the antenna in order to get a volume control. That's how these older radios work. And then the signal, this is your audio chain here, which you can't see where I'm pointing back here, but this is the end of this detector tube. This is the end of the chain, the audio chain. And the plate feeds out here, goes into this, and you've got, as part of this circuit here, you've got C29, and then this is C32, and then this feeds out. So, how is this tone control working? Well, if you short this out, you bring this right to ground, and you effectively take this capacitor out of the circuit. And I don't know, I should look at the value. Do I have the value? Because that might help me understand how that circuit is working more than I do right now. Let's see, where are you? Come on. Somewhere in this collection of paperwork I have a less enlarged schematic, and it will show me also the values. There it is. Let's see. And so this one is C32. So that's a picofarad capacitor. And up here, where are you? C22. That's also a picofarad. And C20, maybe 24 or 29. Let's see what 24 looks like. C24, 0.01. So, let's see. All right, so this is a high value. This is a picofarad capacitor, I guess you could say it's low value. If you short this out, then that basically kills your high frequencies, and that would give you your bottom end. And then as you bring this around and bring this into the circuit more, it will impact the tone qualities, and then you get more treble as you go further up. And ultimately you'd wind up with this going directly through that, and then so that would make it more treble. That's my understanding of it. So why would having a lower value pot here affect this radio the way it does? Well, with the lower ohms here, that affects this voltage here, and I actually checked this plate voltage, and it's about 200 volts, and I want to check what that voltage is once I put a pot in there that's closer in value to what it's supposed to be. We'll see what that is, but I have no doubt that this lower resistance here is affecting the voltage here. And this, where's my B plus? Where's my feed into there? Okay, all right, so this is B plus right here coming off this L15 coil. And so the B plus gets brought closer to, brought down, because you have a 500 k ohm resistor. So the B plus goes closer to, well, it gets lower when you short out this capacitor. You're also bringing this connection down. Are you? Oh, actually, no, I'm sorry. I was heading off in the wrong direction. Having a lower resistance here does affect the B plus voltage, which is here. Having a 4 k ohm, which is double the value of this, should increase the voltage on here and should improve the performance. In order to get our local station, before I was able to use just that little black antenna that comes with a lot of multimedia systems, and I was able to get our local station no problem. I couldn't get our local station. I was having trouble getting signal using my AM transmitter too with it in its current condition. I was going, I had a thought that wandered away. What was I going to say? Oh, well, this wasn't what I was going to say, but let me zoom back out a little bit. So why did I think that this might be wrong when I measured it? That's because the volume control did change its overall resistance, but I admit that I tried to clean the potentiometer before that happened. But in my mind, it was probably likely, it was possible that that this one had changed its value also. It's interesting, there's a crack. It's running. Crack, it runs right across these connections here. I don't know. It probably didn't affect. Highly doubt that affected this potentiometer. The reason, I think I've mentioned this before, but it's been quite a while since I've been doing any work on this. The reason that they used the style of potentiometer that they did in this era was because they were worried about the wiper removing the resistance material. Technology in that day was not great. So by having a plate in between the wiper and the resistance material, they thought that would keep the control working better longer. Of course, we now know that that wasn't necessary if you have decent materials to work with. Unfortunately, these things go bad. They had a lot of trouble with these, and they realized that that wasn't the best idea. So I will probably take this apart. I'm just curious to see what's going on inside there, and I'm pretty sure it's probably similar to the one that was used for the volume control. So that's why I kind of believed that the information on this pot was correct, 2 megs. So this is another example of getting burned by a schematic that's kind of accurate, but not entirely. And I'm surprised that, for the most part, this seems to be pretty good. There aren't a lot of things where I can say, yeah, this isn't right. Thankfully, that was true, because when it came to the capacitor setup, the little cans underneath, I wound up having to come back to the schematic to figure out what was what, because the other information in this paperwork was not accurate. It kind of left me high and dry, and it also left me, allowed me to make a mistake when I was rewiring this stuff up. So let's, I think, come on.
Figure them out. These are easy things. We protect this constitutional. This
Now watch what happens when I.
This system we have. We do it for a reason.
Let's see.
We believe there should be checks and balances on each. We believe there should be both within as well. No one should have unfettered power within.
That's much quieter than it should be. In fact, on one day when I was trying to get this to work, I basically was getting nothing until I hooked up my long wire antenna that I have. So, oh, the other thing, that's what I remember now. This is rather kind of discouraging and kind of scary. Modern, it says 4 megs. I couldn't find anything that was higher in ohms. There's a problem, a possible problem coming down the pike. Modern potentiometers, I think the highest resistance of the potentiometers, when I was looking for a replacement, modern ones was 1 meg. That was the highest they went. Finding a high ohm potentiometer like this one, it's going to be hard. It's going to be very hard. And actually, I haven't even measured this. I just took this out of the package, and let's see, are you in my, out of there. So, I just took it out and I haven't even measured it, and I'm hoping to find that it is what it says it is. Oh boy. That says 3. It says 4 on the package. B86. So it says B86 here and here. This says 4 megohms. I'm not happy with this, though, because, come on. That's not ideal. I don't think there's anything wrong with that meter, but we're just, for the fun of it, we're going to use another meter just to see. I know these meters are pretty close. I think I compared them. They weren't exact, but they were pretty good. So let's see. There's 20 megs. Let's go here and here. Yeah, it's about the same. So, it's about a meg off of what it's supposed to be. And let's just, come on. I'm just checking to see how it behaves. I am going to clean this before I put it in, but I just want to know. Yeah. The pot seems to be working okay. It just isn't the value that it says it is. Well, here's what I'm going to do. Yeah. So what I'm going to do is, oh, left that on. Not good. I'm going to, let's put you away. Unsolder. That's what I should do. Put my soldering iron on. That out of the way. So what I'm going to do is, I'm going to solder two of the wires to this. I'm going to leave the ground wire connected, and I'm going to just get rid of the unsolder those two. And in fact, actually, can I? Yeah, I guess this will let me do what I want to. Yeah, it'll let me go where I want to. Can I go further? Maybe? Yes, I can. Here's some light. Oh, stop. Alright, so there's my little pot. And I tried to make sure that I got everything plugged into the right thing. Now I did connect, or yeah, talk. I did mark the plates on the tubes up above on the top side, because you can't get to the bottom side. So thankfully they have little metal, I guess they're probably rivets or something, that you can get to test the voltage on the tube. So I'm curious to see, put that in there, and do I have, should be this one, I think. That's not right. That's weird. I'm pretty sure I didn't cross these wires, and I don't think they would work well if I had. Let's check this out, though. Um, 563 k ohm, and that's megohms, almost 3 megohms. Why? Did I make a mistake? Let's see. Am I losing it? Oh, okay. All right. I didn't remember that there is a capacitor here. So if I try to measure from here, it's got to go through that capacitor and go up that way, and so apparently it's following other paths to give me a number which is not right. It's not the correct number. Alright, so I'm going to make an assumption that the connection is correct. Alright, so well, ow, get out of there. Okay. As you can see, I just simply tack those on there, and given my history with things over time, how things have held up over time, I might not have done anything more than that. I mean, frequently I will actually put the wire through the hole in the tab, the connection tab, but sometimes I won't. Depends on the mood. All right. Let's see. I want need another jumper. So what I'm going to do, actually, take you off of here, and come on, go. Put that on ground. Now this one should be the middle. So what I'm going to do, I put my pot. Oh, there you are. So here's my pot. Here's my ground. Alright, and this should be the middle one. No T's in middle. Anyway, then this should be the last one. Now theoretically, this should work. We'll see. Let's see, is there anything else I should be worried about? I don't think so. So let's fire this up. And come on. Some of you may notice that I've got a yellow dot on there. I have a yellow dot on the top side that tells me that wire went to that spot.
Tucker, who I really like a lot, and I think is an important figure in our movement, and Fox, I slept friends here at the show. I have an obligation to discuss the story. And Jim knows because why wasn't on? Jim, didn't you listen one day to the show when I was recording on Friday? I don't know what you. Jim might have been in the studio on the mic. It's a long story, folks, but the mics here are like all connected. Jim can hear the podcast. The Fox people can hear the.
Whoa.
Without.
Whoops. Sorry.
Aliens and the planet, Uranus.
Okay. Well, I didn't expect that. What I just did is I hooked up the long wire antenna, and
In my Fox show, a lot of times I would record it on Friday nights. Sometimes we were live, sometimes Friday we'd recut some portions of it.
So now I've got much better bottom end. I got a lot more signal.
With about, 15 minutes of commercials, roughly. But Jim, you heard that night. It takes what, about 2 hours, right?
Well, given my options, that may be what I have to do.
It's not me, folks. You got to get guests seated. Microphones don't work.
All right, let me.
That's why live TV is so hard. You don't realize it.
I'm going to kill that for now. I'm going to hook this up, and I want to see. Put that there. Let's see what my voltage. I know that it was 200 with the other pot in there. This is going to get me where I want to go, I hope. All right. Come on. Let's go. That says 200 volts still. Huh. That's saying exactly the same. Well, that's puzzling. That's very puzzling. I don't understand why that did not impact the voltage on that plate unless I'm on the wrong tube. But one of the things that you'll find out if you get all of this paperwork is that it shows you where all the tubes are. And this is the front, this is the obviously the back, and that's where those connectors are, which is those actually here. Yep. And it tells me that the detector is right next to these, which are right there. So when I checked everything out very carefully, ooh, interesting. I just noticed something that I didn't pay attention to before. No. I was hoping it might give me the pin layout. And what I wound up doing is I found out where the filament I thought I'd gotten rid of all my noises in this thing. I may have to re-clean that tube socket. So anyway, so I had to figure out where the filament pins were, and then work from there to find out where everything else was. Because with these old tubes, which I don't have one floating around right now, they have 5 pins on the bottom, and then they've got a grid connection on the top, and the orientation is controlled by the spacing between the pins on the tube. So I'm pretty certain that I have the tube, or have identified the plate correctly, but let me think. Am I wrong about what I was thinking? I don't believe so, because I would expect that a 1 megohm difference in resistance between your B minus and B plus would pull the voltage down, but it doesn't. Sure made a big difference in the reception on this thing, huge. But it makes me wonder how it would behave if I had the right value there. I'm going to play around with this a little bit and see just how it behaves. I'm going to use my AM radio transmitter and see how that works with this new pot, and we'll just see. So let's zoom back in here, because I was going to do this and I got myself sidetracked. Alright, what would happen if I were to connect between here and, well, if I were to take this lead off and put a 1 megohm resistor in there, what would happen? And how would it impact other things? I know it would affect the tone control, and it may affect this part of the tone circuit, so you may not have as much treble, although it seems like it's got plenty right now with that. Let's experiment. And since there is a lot of voltage on this, I don't really want to play with it while it's hot. Okay, well, I've been playing, and you can hear from the humming that this is not making things entirely happy. While I was playing, I decided to take this apart, and it's the same basic idea as the volume control pot. You get this metal plate that rides against the resistance material, and if you're on this end, this should be down at least in the k ohm range, and it's not, it's megohms. If you go from this side over, then you're in the k ohm range. But basically the bottom line for this is that this is a dead pot, it's toast. So, now, what I did was I took this old antenna from this old radio that I had, and I hooked it up. It's not it's not attached to the big antenna wire I've got, and the local station comes in really well. So if I part with this radio, I'll probably include this antenna with it. And so right now I've got my CD player running, and got it tuned in to the AM radio. So it seems to work pretty well. Let's go back to the other. Where are you?
WBTN every day from noon to 2 p.m.
1370 AM, WBTN is your community radio station and gets most of the support from listeners like you.
So it's got ample volume there. We'll turn you off. It's got ample volume using that antenna. So the long wire antenna is not necessary with this. I do have this grounded. Let's just, for the fun of it, see what happens when I unground this.
Guess what? Today's your lucky day, because now you can buy a car, truck, or SUV, just about any vehicle. It's true. Bad credit doesn't matter. No credit doesn't matter. Bankruptcy or divorce, it just doesn't matter. As a matter of fact, your job is your ticket to...
So if you unground the chassis, then it makes a slight difference in volume. Now the other thing that I played with, down here I have a resistor. This is a 1 megohm resistor. I put that in series with my control here. So let's go up here.
8909.
And I wanted to use the local station so you could see if there's a difference in how this behaves. Nothing. So
The most informative 3 hours you'll have.
So, here's what I'm going to do. Turn that off. As you can see, taking this 1/8 megohm resistor out of the circuit made no difference in the reception, and it didn't seem to affect the tone. I played with it a little bit off camera, and I didn't see a difference. So it looks like this control will work. In order to make sure this has enough signal so that it doesn't misbehave when you're cranking the volume, or if you have to crank this up near the top of its volume, it doesn't seem to like that. It's possible that the volume control, because it's not the exact values that are called for in the schematic, is not happy at higher volume levels. But if you have a decent antenna and you can pick up local stations with decent volume, it's not going to be an issue. And I feel like I'm kind of without any choices, any options, because I could order another one of these, dual section pot, 10K and 50K. I could order another one of those. I probably should talk to the guy that sold it to me, but I could go through all that trouble and wind up with what I'm seeing here. That is not the same as having a 4 megohm pot. I know that. I was expecting, though, to see a difference in the reception performance. Because if this pot, there we go, if that pot killed the reception like it did at 2 megs, bumping this back up to 4 megs I thought would affect the reception, and it doesn't. That leads me to believe that I can put this in there and it should be okay. Okay. Well, I just saw something, and this may make sense of my confusion. It may not. But let's take a peek at what I just realized. Alright, let's zoom in some more. Why not? Alright. Ask myself the question, self, what kind of voltage is here? And self answers, why, it's DC volts. You're so right, self. Follow this up through this resistor. What is here? Oh, it's a capacitor. What happens when you have DC on one side of a capacitor and a ground on the other? Why, nothing. Because DC can't travel through a capacitor. Again, self, you are so right. Alright. So, that's probably why the DC voltage didn't change here. But that's also why the reception performance did change, because the RF signal can travel through a capacitor, and having a lower resistance capacitor or resistor here will affect this RF circuit or audio circuit, because this is a detector. But regardless, the signal coming off of this can go through this, it can be impacted by this, and that is what's going on. Oy, oy, oy. You gotta think. You gotta think. Well, anyway, so I think I just solved my own mystery. The voltage here didn't change because of this. The reception did change because of this. And apparently 3 megs is enough to get us where we wanted to go. I'm kind of puzzled that putting a 1 meg ohm in here didn't change things. That was the right place to put it. I really don't want to put it here, because that would affect the way this control would work, because when you put your control all the way around here, it's supposed to connect this to ground with a 1 meg ohm resistor in between here and here. This would not be at ground, and your tone control would not work correctly. You would lose probably a lot of your bottom end. So, I have hammered down long enough. I fix this, and polish this up, and then come back and show you the end result. I know I'm going to test this a little bit to see if it really behaves properly or not. Alright, well, I did get the volume control in, and I did polish the front of this. Now I know I probably didn't need to. Most of the time nobody's going to see it, but I wanted to experiment. Always experimenting with something, it seems. Trying to learn things. The question is, should I use, this is quad 0, this is fine steel wool. So this film, I'm assuming this is nickel plated, but I'm not sure. But this film is hard to get off. If you take this and take some of this Blue Magic polish, it takes it off fairly quickly, but even after polishing it separately with this Blue Magic without the steel wool, it leaves some scratches behind. So I wasn't excited by that. So I decided that I would try it on the side of this, but using Brasso. Now Brasso, stainless, chrome, aluminum pewter, bronze. It's a bit coarser. I was looking to see, it doesn't mention nickel plated things, but this side was done with this, and I'm not sure. I mean, you can't, in the camera it looks really shiny and really nice, but if I put a light on it and look at it more dead on, it seems a little bit cloudy, and I don't know if that's because I used the Brasso or if it's because this side it's just the way it is. But my conclusion is that regardless of what I do, I don't want to use stainless steel on something like this anymore. This came out beautifully. There are no fine scratches, and there's very... When you're polishing something and scrubbing on it, and you put a fair amount of muscle in it, you can develop some very fine scratches. It's looking actually pretty nice. So the bottom line is, whether I use brasso or not, I don't want to use stainless steel. Even, I don't know if they make a finer stainless steel in Quad Zero or not, but I don't know. And there might be something else other than this that I could use along with this. But what's nice with this is that it does knock down the film a lot faster, and then I follow up behind with this, and it gives it a nice finish. And the brasso does almost as good a job as this does in terms of the finish. But I use this, and I think I've mentioned this before, is one of the things this does that doesn't, is that this leaves a film on the metal to protect it and keep it from corrosion, keep it looking good longer. That's what they claim. And I can see a difference. I think I used steel wool alone on some parts of this, and then I can't remember what I used afterward, but when I use this on something that I polished before, it immediately looks shinier. It comes up, it just comes up looking better. So definitely this, and my hope is that the end result is going to be what it's supposed to be. One of the things I ran into, I don't know if you can zoom in there, let's see. Let's see if we can. Are you going to do that to me? There we go. Well, you can't. It's not doing what I want it to. It's looking... Well, the camera isn't... Well, maybe you sort of can. When I was polishing, I got to hit the bottom of this with some of my polish, and I just rubbed it down a little bit to get it off. And starting from here down, it's a lot shinier. This has been polished already. And I may have used brasso on this part. I can't remember. I know I used steel wool. And so I was debating about whether I would take this off and polish it further with this. And based on what I see here, yeah, you can see down there, it's very shiny. I am going to, because it'll look a lot better, and like I said, it'll protect the metal a little bit. I most likely won't have this radio, but it would be nice to send it down the road knowing that it's looking good and it's going to stay that way for a while. Of course, there aren't that many people that are going to go in behind the radio and dust it and clean it, I suppose, but start off looking good. And the other thing is that when you have dust on something, dust, dirt, whatever, can collect moisture, and so it's good to have something on there that will help protect it. And there are spots on this, like right back here. I don't know, can you see that? I don't know. Let's see. Come on. Well, you can see a difference. Unfortunately, there's a spot right here. Oops. There's a spot right here, this area, that the plating's gone. It's just not there anymore. And there's actually some rust that started forming there. Not sure what caused that, but the plating has disappeared. I don't know what caused it. I don't see any obvious... At first I thought maybe somebody had this disconnected and it shorted against the chassis, but I kind of doubt that. So anyway, let's zoom back out. Alright, so I want you to hear how this sounds with this new volume control in it. Let's see, did I pause it? Okay. a lot better. So, as you can tell, this one's working a lot better than the 2 megohm that I took out. I was kind of surprised that when I added a megohm to this 3 megohm pot that it didn't make a difference. But it didn't seem to. So, didn't expect that. It worked out well because this supposed 4 megohm pot measured out at 3. But that's the second time that a Central Lab pot has done that. I think because I got a Mark Opat, I think. I got this pot from him, and I gave him the specs, and when I measured it, it didn't seem, it wasn't what I expected. It was like 10 megohms short on one of the measurements. I can't remember what the other one was. I think the other one was maybe pretty close. But this one, this pot has never been used. I cut the shaft down. The shaft was the original length because these are designed for replacement pots. So and the number actually was on this that matched the number in the box. So I don't really know why that has or wasn't the right value, but or what I expected it to be. But anyway, so here's where I'm at. Oh, the other thing is some of the squirreliness of this radio, where it was squealing. I don't know if you've heard that or not. If I could turn the volume up too much. Let's pause that. These radios have shields on them for a reason, and it's because they do not operate as well as they should without the shields. So if you wind up working on one of these and you have the shields off and it's doing something funky, whistling, squealing, doing bad things, maybe motorboating, put the shields on every tube and put the caps on and see if the problem goes away. It might. Because like I said, these things are touchy. TRF radios work okay, but they have some quirks, and one of them is that they like to whistle and squeal unless everything's exactly right. I think I mentioned before, and I'll mention it again, there are a couple of coils, there are 3 coils in the circuit diagram that were put in there to add stability to this radio. Because I guess without them, maybe it was doing bad things, and that was their fix. So at this point, this is done. I'm going to call this finished. You could hear the speaker. It sounds good. Got good bottom end. The tone control goes up to really nice, really as high as you'd want to go with a tone control, and it gives you good bottom end. I think the other one was giving me a little bit more bottom end, but I think it's actually working pretty well, and I'm very happy. I thought I was having some distortion issues, but again, actually I did have the shields on, and I thought I was getting that. That will be the last thing I will do is, well, all of these are coming off. They're all getting polished. And then they're all going to be put back on, and I'll test the radio. I'm actually going to finish polishing the top of this and in the back, and probably the side, because if you look in the side of this, you can see this. So so I will clean that as well. That is pretty nasty. So and the side I probably will use Brasso on because, well, it's a lot faster, lot less work. So I'm wrapping up this part of this radio. There's a bunch of things that are happening the very near future, which will prevent me from doing much more on this. But I really do, I want the case, which I think you saw at the very beginning. I believe I did video the case. It needs a little bit of work. It's actually not in bad shape, but the top needs to be redone, and actually I think there might be some damage on one of the sides. So so that's going to be the next thing I do for this radio, but it's not going to happen right away, unfortunately, because of other things that are happening. I might get to do some other smaller projects, but as far as this goes, I'm calling this finished, and basically it's just cleaning it up, putting it together, making sure it still works okay, and then moving on to the case. So we're going to wrap up here and move on to the next part.